Okay, so welcome back to my channel, and like I promised, in this video we are going to see the solution to an integral equation. So a solution to any equation is basically values, or let me say functions, or yeah, whatever values that satisfy the whole equation, right? Yes. So when we're doing differential equations, we got to know that when you put in the function and you have the whole equation satisfied, that becomes the solution to the differential equation. Same thing applies to this place. Once you're able to incorporate the value or the function of the solution into the whole integral equation, you're supposed to get an identity, and that should actually show that the solution actually fits. Okay, so with the first example, we have phi of x being equal to 5 on 6x minus 1 out of 9 plus 1 out of 3, then the integral of whatever you see there, x plus t, phi of t dt from 0 to 1. So first of all, I want us to pause the video and try to classify this integral equation. Okay, so you see that the function we are looking for, which is phi of x, is found outside the integral sign as well. So this is going to be a second kind Fredholm's integral equation, because you have the integrals or the limits of integration being constants, right? So you have a second kind Fredholm's integral equation, and you have the free term not being zero. It is a function which is not equal to zero, so this makes this whole Fredholm's integral equation homogeneous, non-homogeneous. Okay, yeah. So that's the classification, and you can actually see that this is a linear integral equation, because the unknown function, isn't any transcendental function, or it isn't to any power apart from 1. Okay, yeah, so this is a linear integral equation as well. So now let's get it. So definition, I'm not going to really write it. A solution to an integral equation is a function that, when substituted into the equation, okay, you're going to have an identity. Okay, yeah. So this is what we are saying the integral equation is, the solution to the integral equation is. So it means that when we put in x, all right, wherever we are going to see phi of t, or wherever we are going to see phi of x, we are saying that we put in x, okay, then we expect that the left hand side should be equal to x on the right hand side. Okay, yeah, so let's do that pretty quick. So the first question, we have our solution. Look at it shut. So with the first one, we have phi of x being equal to 5 on 6 x minus 1 on 9 plus 1 on 3 integral 0 to 1. You have x plus t. Now you're saying phi of x is given as x, so phi of t should be equal to t. So I put that thing over here, so I'm going to get t dt. Okay, so now let's get this done. We have this being equal to 5 on 6x minus 1 out of 9 plus 1 on 3, the integral from 0 to 1 of tx plus t squared dt. Okay, so dt. So now let's go. We have 5 on 6x minus 1 out of 9 plus 1 out of 3 multiplying. We're going to have t squared x, okay, divided by 2 plus t cubed all on 3 from 0 to 1. And this is going to give us 5 on 6 x minus 1 out of 9 plus 1 out of 3. When I put in 1, I'm going to have x on 2 over here plus 1 out of 3 minus all these side. when I put in 0 over here, I'm going to have 0, so I can actually end here. Then I'm going to have 5 on 6, x minus 1 out of 9 plus x on 6 plus 1 out of 9. So you can actually see this canceling that. Then we are left to simplify 5 on 6x plus x on 6. So we have 5 on 6x plus x on 6, and this gives us 6x on 6, which is actually x. So we have gotten to see that phi of x is equal to x. So the identity has been gotten over here. So it actually means that this solution, or this function here, is actually the solution to this integral equation. Okay, so you can pause the video and try to solve the second one as well. All right, yeah. So with the second one, we have u prime of x being equal to 2 on 3 plus integral 0 to 1 tu of t dt. But we are given u of x to be equal to x, right? So it means u of t should be equal to t. So but u of t should be equal to t, so we put that thing over here. So we have u prime of x being equal to 2 on 3 plus integral 0 to 1. Then we have t times t dt. So that's going to give us u prime of x being equal to 2 on 3 plus integral from 0 to 1 of t squared dt. So we have u prime of x, and that should be equal to 2 on 3 plus t cubed on 3, starting from 0 to 1. So you have u prime of x being equal to 2 on 3 plus t, oh, hold on, I'm sorry, 1 on 3 minus 0, right? So that's actually going to be 0. So I have this. So I have u prime of t being equal to 2 on 3 plus 1 out of 3, which gives you 3 on 3, which is equal to 1. So we actually are saying that u prime of x is equal to 1, right? So this is actually making us know that if we differentiate u of x, we should get 1. So let's go back to the solution and see. U of x is equal to x. When you differentiate this whole thing with respect to x, you have u prime of x being equal to 1 as required. So you can actually say that this is a solution to the integral equation. Okay, yeah. So in our next video, we will be trying to know how to differentiate under the integral sign, since it's going to be a very key thing for, like, we are going to need that in our solvents in our subsequent videos. Okay, so see you in the next video, and subscribe to the channel and turn on post notifications. See you in the next video.